So there are many software to construct phylogenetic tree, and also to do multiple sequence alignment. Yeah, I just want to introduce one that is Clustal. This probably is the most popular software for this purpose. And Clustal was developed by Des Higgins back in 1988. And later, it became an advanced version called the Clustal W. And then this version has been cited for more than 70,000 times. That really shows the power of this tool and how useful it is. And then later in 1997, Clustal X, a graphical user interface was added. But now the latest version actually is so-called Clustal Omega. It applies this method called hidden Markov model. The hidden Markov model basically means you study the relationships between neighboring sequences and use that sequence relationships to help you to do the alignment. So that's actually more powerful than just comparing to one position, because when you compare with hidden Markov model, you actually compare with for them at least two letters between one species or one gene with another. And this version actually is pretty efficient. It is not as accurate as some of the more advanced methods, but those methods they are more accurate, but also more time-consuming. Typically, they cannot handle many sequences, while Clustal Omega, you can easily handle thousands of sequences pretty fast. And you can also use this web version to run your sequences. We are going to demonstrate that a little bit later. Here you see that the basic idea that is actually very simple. So you have these sequences, and then you first conduct pairwise sequence alignment between any two sequences. And then you do the neighbor joining method. That is, you ask this question, among all the pairs, which two sequences form the strongest pair in terms of sequence identity? So if you have a high sequence identity, you connect that one first. Then you do the next pair, etc. And then you form some guided tree. And then you do this global alignment of all the sequences, and then do this multiple sequence alignment. So that's kind of the idea behind the Clustal W. So it is a very simple, it's of course a heuristic algorithm, but in practice, it is pretty effective. So when your sequences are very similar, that is between any two sequences, you have a pretty high sequence identity, let's say more than 80% sequence identity. Using this method is probably good enough. It doesn't make too much difference between this method and the more advanced methods. But if your sequences are very diverse, that is, they do not have a lot of sequence identity, then you probably should use more advanced sequence alignment and phylogenetic tree methods. So I will do a demo about Clustal Omega, and also show some other tools you may be able to use. Yeah, so this is actually the European Bioinformatics Institute job dispatcher. So it has many popular tools. So here we just want to show Clustal Omega. So you can actually open Clustal Omega, and it's very easy to use. All you need to do is just paste a sequence. Here, I just choose 4 of the sequences. It's a BATC1, 2, and 2 BCCP genes. So you just put this so-called FASTA format and put one sequence at a time, and then that's how you need to do. So it's very simple. Yeah, in fact, you can have a different format. So we'll talk about the Clustal format. You can also add some other formats. Some actually is by other popular tool. For example, this Philip is one of the most popular tools for phylogenetic tree analysis. So you can choose any format. So let's say in our case, we just choose a default. Yeah, so you can just put a title, I say BADC. So you see it's actually very simple. Yeah, then you just submit. That's how it takes. Of course, in this case, it takes a little bit of time. So while we're waiting the result, I just want to introduce this job dispatcher, because a lot of bioinformatics analysis, you can just go to this site. And then here you see that your written jobs, and you can delete them if you don't want to run them. And then you see here are the two categories. So you have a pairwise sequence alignment. Yeah, so some of them it's a little more accurate than BLAST. So you can do even more detailed analysis. And then you see polling function. So this part I'll talk about later. That is how to search protein domains, protein family, etc., or protein motif. And then you have an RNA analysis. Yeah, so here we just talked about this Clustal Omega. Majority of cases, that's probably good enough. But I mentioned that sometimes you probably want to try additional tools. For example, I often try muscle T-coffee because they are more sophisticated. They handle more divergent sequences a little better. This actually is reflected in this protein structure prediction. So in early days, I participated in this CASP for protein structure prediction. So I know that if I build multiple sequence profile using, let's say, muscle, and then I predict structure, the performance is probably better than using Clustal to build a profile. So these tools, they do have an added value, but it just depends on what is the context. If your sequences are very similar to each other, you probably do not need to use them. But some other cases, you may want to try these tools. And all these tools are web-based. It's very similar to Clustal. You just paste sequence, click button. That's how it takes. And here, there's some phylogenetic analysis tool. In fact, here I just want to show once you get a Clustal results, you can just copy and paste the results here as the input. Then it gives you a little bit of refined phylogenetic tree construction. Yeah, somehow it doesn't show up. Yeah. So yeah, this is a simple phylogeny. That is we can show the example. So this is a Clustal Omega as an output. You just put it here, and then you have some choices that you just submit. So you will see Clustal Omega gives a phylogenetic tree directly, but this one refines the tree a little bit better. Again, it depends on whether you need to do that or not. So let's see. Yeah, our result is out. So these are the sequences that we copy and paste to the Clustal Omega and gives you the alignment. So I already explained how you can utilize such alignment, but you see that the alignment actually is pretty clean. And some parts actually, I'll have to say, for example, here, Clustal Omega doesn't do a great job. In my opinion, here probably can be realigned a little bit. So sometimes that's what I do. I manually readjust the alignment based on my experience, or based on some knowledge from my collaborator. So do not just trust the output, but rather you may need to tune a little bit. And then you can save the result in file, and then you can see the tree, for example, gives you a simple tree. But this tree is not refined. So that's why you could copy and paste Clustal output into that phylogenetic tree construction program to regenerate the tree. So this is actually the simple tree. You can adjust a little bit to see the results, and then you can view the results in a different way. So there are quite some viewer to see the results. So you can check them out. I think really give you a lot more in-depth visualization.